Hello again everybody, and welcome to this video lecture on Octave with Spice. And we are now in chapter 2 and they're the part of matrices and vectors. So GNU Octave, so it's a MATLAB clone, and MATLAB of course comes from the matrix laboratory. So math doesn't mean mathematics there but matrix. And what does this mean? It means that all the basic arithmetics is designed to work for matrices. So everything is a matrix. That's the thing to learn from this. So how do you define a matrix in Octave? So it's basic, or the simplest way is to define it row by row, and elements in a row are separated by a comma or simply by a space. And the rows are separated from each other by a semicolon. And again, a note here, so we have already seen the semicolon used in one sense. It was used as a shut up, please be quiet operator. So if we end a line with the semicolon, then Octave knows to be quiet and not echo back what just happened to us. Now there is a second use of semicolon here, and that is simply to separate rows in matrix. And how do we refer elements of the matrix? So if A, now we use capital A for matrices. Again, remember that Octave is case sensitive, so for example small a and capital A are different variables. So if capital A is a matrix, then A, and then since it's, well, we don't use subscripts, we use this parenthesis notation, so A and then in parentheses ij is its element in ith row and jth column. Okay, what does this mean? Let's have a very straightforward example 2.10 about matrices and their elements. So in this example we consider just for fun, I hope you have fun with this, matrix A. Again, in mathematical notation it's usually boldface, capital A, and it's defined like this. It has 2 rows and 4 columns, and the elements there are just I use this number 1, 1, 1, 2 and so on. So you can easily see, so for example 23 is the second row and third column. Okay, so how do we write something like this for Octave? And we use it, well, we did it as explained here, so let's do this discussion in Octave console. So I start with Octave here. Again, you remember it's some icon like that, and you should have something like this. So let me press Ctrl L just to clear the view, and let's see what we are supposed to do. So we have to introduce a matrix like this. So we start A, now it's a capital A, then equals. You might notice that I put spaces around the equal signs. It's kind of a matter of taste. You can do it or not, it doesn't matter. And then we have, okay, it's actually not given here. The matrix should be given inside of brackets like this. I'm sorry, I think it's not written here, but in any case it's here in the example, so maybe I don't change the text. So we start, we open a bracket, so something that comes inside is a matrix. So let's see, we have first row is 1, 1, or 11, 12, 13, 14. So 1, 1, 1, 2, 1, 3, 1, 4. Okay, I could have put here commas like this, that would be the same thing. I usually don't put there commas. Sometimes I do, sometimes I don't. Okay, so that's the first row. So now we need to tell Octave that next comes the second row. So here we have a semicolon. So this means that the row ends here, and now comes the second row. What do we have in the second row? We have 2, 1, 2, 2, 2, 3, and 2, 4. And let us not forget to close the bracket. So now this should probably be this kind of matrix. And let's just press enter. Let us not put semicolon here. So we just want to see if this looks correct or do we get an error message. Okay, it looks correct. So now Octave tells us back that A is, and now it understands that this is the first row and this is the second row, and then it prints it back kind of formatted so it looks more or less like a matrix like here. Okay, assigning or introducing matrices is as simple as this. And now we can look, for example, how do we get the elements of the matrices. So A, usually in a mathematical text, we have written 1, 3 like this. So in the context, as a human reader, we understand that this is not 13th element, but this is the first row and third column. So sometimes there is a comma here. So the first row is here, third column is here, so this would be 13. So how do we get this from Octave? So A is now a matrix. Again, if I just press A, it tells me what is the matrix A. So if I want to have its first row and third column, that's an element there. And it gives that it's actually 13. And again, you see that it's now, this is a calculation or something like, we ask something from Octave and it gives us the answer, but we are not asking or assigning the value of this answer to any specific variable. So it will use this temporary variable ans or standard variable ans. So answer will be 13, which is like this. Okay. Then we can ask, for example, the third row and first element. What do we get? Okay, we get an error, obviously, because we are asking for a third row. So this is the first row, second row, and a third row would be here if it if it existed, but of course it does not exist. So we get an error message as we should, and this is the, it looks like this error colon. So again, it means that error happened. Then A3 comma something. So okay, so there is an error in a third row, and what kind of error we get? Out of bound 2. Okay, so dimensions are 2 times 4, so this is a 2 times 4 matrix, 2 rows, 4 columns. Okay, so this is an error message we get. All right, so a little bit of stuff how convenient GNU Octave is a matrices. So the matrix algebra that you have learned probably, hopefully in a linear algebra course or something like that, it works in the obvious and convenient way with Octave. So for example, if A and B are matrices, I mean they have to be, we assume that they are matrices with suitable dimensions. So if you want to transpose a matrix, so there are many definitions or notations for the transpose in mathematics. Sometimes there is just a comma there or hyphen. No, not hyphen. What do you call it? This kind of mark, or then there is a T like transpose. Well, in Octave, it's simply you use this. I don't know, single quotation mark. Let's call it like this. So it's like that. So simply we have A here. So A's transpose is A, and then capital A, and then this single quotation mark. And yes, this is what the transpose does. It changes rows and columns. The opposite. Okay. Then there are, sums, A plus B and A minus B. They are obvious. So of course the dimensions have to be here the same. If they are not, then in principle they are not defined. Then the matrix product. Okay, the star, as I said, it's a product for normal numbers, but it's also a product for matrices. It works the obvious way. And then the matrix power, a to the power n, a hat n. This works the obvious way. Inverse matrices, a to the power minus 1. Well, you can just use the a to the power minus 1. Or you can use inv as inverse of a. And then finally there are division. So what does it mean to divide a matrix by another matrix, or actually by a vector? Well, if you think of it from an algebra point of view, so if you want to solve a system a times x equals b, so a is a matrix, x is a vector, b is a vector, this can be solved by the left division. So this is the backslash now. So x is a backslash b. And well, now I leave it to the reader to guess what does the right division, so not backslash, but the forward slash does. Okay, there is left division and right division. The reason for this, why they are different, is that, as you remember from elementary courses, I hope that for matrices a times b and b times a are not the same thing. So that's why left and right division are two different operators. Finally, these basic operations for matrices, what we need is an identity matrix. So if you remember from the linear algebra course, an identity matrix is a matrix that has ones on the diagonal and zeros otherwise. And how do you define an identity matrix in Octave? Also the same as in MATLAB. Of course, in mathematics we usually use it as a capital I, or sometimes you put the subscript n, so telling the dimensions, the dimension of it. This is not used in Octave. The reason is that, okay, if I just put capital I here, it gives you answer is 0 plus 1 small I. So capital I is actually an imaginary number, square root of minus 1. The square root is sqrt, so it's the same thing. So that's why the I is not used for identity matrix. Instead, it's I, kind of like I, you know. Okay, this is a terrible pun. Sorry about that, but that's the way it is. So, for example, I4 gives a 4 times 4 identity matrix. So here is the answer. It says that it's a diagonal matrix. This is a technical thing, you don't have to care about that. But in any case, here you have it. It's a 4 times 4. It's zeros otherwise, and ones on the diagonal. Okay. Of course, there are lots of matrix algebra that I could explain here. We probably do not use so much matrix algebra in this course, so I'm not going into the details, but you can of course find, well, I hope that everybody has studied at least a little bit linear algebra. What we use a lot, however, is something that's probably not in the linear algebra course so much explained, is that we use block matrices. So what is a block matrix? It's a matrix that we think of them as blocks. So some columns and some rows are some block and so on. And we will cut matrices into blocks, and we will paste many blocks together into a new matrix. And this is something that's is rather typical thing that we do here. And this can be, I mean, this can become very complicated very quickly. So how does this work? I mean, logically it's not so difficult. It's kind of, I would think, relatively straightforward, and simply if you really think about I don't know, if this square here is a matrix, then splitting this into two blocks is simply like how do you cut it like this, and then you can paste them this way or this way or whatever it's. I mean, this idea how you physically would cut and paste rectangles, that's pretty much how it works. But of course you can do a lot of cutting and a lot of pasting, and it becomes very complicated very quickly. But let us see, in any case, have a couple of examples to see how this works, and to really understand and get used to it. You just play around with Octave, and this is what we are going to do. So we'll see how this works. But for this, I think that we need a little bit of notation, and also, since I want to keep these video lectures relatively short, so this is now looks like 16 minutes, so we will continue this in next video lecture. So for now we have learned how to define a matrix with Octave, and we have looked a little bit about, or explained a little bit about the basic operations, how they work with Octave in the natural way. So that's this lecture. In the next video lecture we cut and paste matrices. Bye.